Hello and welcome to World Talks with me, Ashim Kumar. Europe's relentless heatwave is no longer just an environmental crisis. It is becoming an energy crisis. Exceptionally low water levels on the Danube are threatening nuclear power generation in Hungary and Romania, exposing the growing vulnerability of Europe's energy infrastructure to climate extremes. Joining us is Jakub Wiech, he's host of Elektryfikacja. Jakub, hello and welcome back to TP World. Thank you very much for taking the time.
Hello, good evening.
Good evening. So just very briefly, if you would, the connection between the water levels in the Danube and the operation of a nuclear power station in Hungary or in Romania?
Well, that's actually a complex question, because to understand that, you have to understand how do we generate electricity in objects such as nuclear power plants. And let me explain this very briefly. Well, first of all, to generate electricity in a power plant such as, for example, Paks power plant in Hungary or Czernavoda power plant in Romania, you have to boil the water. While boiling the water, it changes into steam. The steam hits the turbine starts to spin, and that's how you generate electricity. But then the water has to become, the steam has to become water again. And to do so, you have to cool it down. And facilities such as Hungarian Paks or Romanian Czernavoda uses the water, the river water to do so. It uses the so-called open cooling circuit to cool down the steam to make it water again. And to transfer the water from the river to the power plant, you use pumps, such a large pumps that absorb the water from the river and push it through the pipes in the power plant, and then exhaust it back to the river. And when the level of the water in the river is too low, the pump cannot work because it pumps also the air, and it's very dangerous to the machinery in that pump. So it has to be shut down or limited in its operation. So that's why you have to have a sufficient level of water in the river to use the pump, and you also have to dispose the proper temperature of the river of the water in the river to use it not to create environmental catastrophe. And both of these conditions are not met right now in the Danube River. For example, the authorities in Romania are now fighting to keep the last unit of Czernavoda power plant running. They are even demolishing the water bank to push a lot of additional water into the pump, to pump it into the facility, into the nuclear power station. And this is what you see right now in the screen. This is the video from the demolition of the river bank that will make it available to flow some additional water into the pumps to the Czernavoda nuclear power plant, because otherwise you will have to shut down the only one remaining nuclear reactor in Romania that generates 10% of the country's electricity, and that could be a serious problem for the electricity system, not only in Romania but also in the neighboring countries.
Okay, thank you very much for that. That's a really clear explanation. Now, tell me, Jakub, has this situation ever arisen before, either in Europe or elsewhere?
No, this is an unprecedented event when we face the possibility to shut down completely the operation of the Paks nuclear power plant in Hungary. This is the first time in the over 40 years history of this nuclear power plant when it faces a possible shutdown because of the Danube River level. So it's unprecedented, it's a rare event, but it can become more frequent in the upcoming years because of the possible ongoing heat events that will occur in Europe due to climate change and due to the rising temperatures here in the European continent.
Okay, but it hasn't happened anywhere else either. In other words, it's never happened anywhere in the world. Is that correct?
Well, not really, because we faced a lot of similar cases in which we had to limit the operation of the power plants due to the low levels of water in the rivers, or to the high temperatures of that water. For example, in Poland in 2015, we lost almost 2 gigawatts of power due to this factor, because the level in the Vistula River was too low to conduct the operation of Kozienice and Połaniec coal-fired power plants. So we had to limit the operation of these units due to this condition. And this is a similar situation in Hungary and Romania right now, but the extent of the situation is much broader. It's a very unique situation for the entire Central European energy system, because it is now forced to operate in quite severe conditions, and the governments in Bucharest and in Budapest, they are working really hard to keep it running, to keep the energy system running, because they know that any kind of mistake in this operation may lead to very serious incidents in the not only Romanian or Hungarian energy systems, but also in the energy system of the whole Central Europe. It can also lead to a blackout, so to a very serious failure of the energy system that can
Understood.
be also...
Jakub, understood. It's a very serious risk here, a very serious threat. My question, though, is why is there no backup system? I mean, surely there would have been a risk assessment done at some stage. So, I don't know, coal-fired or oil-fired power plants as a backup. Was that ever considered or implemented?
And in this question, you can see the entire uniqueness of the situation, because we have a lot of backup. For example, nuclear power plants are considered to be a backup of renewable power, because they are considered to be a stable generation, the generation that is not affected by the weather in any way. But now the situation in Central Europe shows otherwise. So we are actually losing our backup. As power plants such as coal-fired power plants, or gas-fired power plants, or hydro power plants, and also nuclear power plants are considered to be the stable ones, the ones that are running despite of the sun, despite of the wind. They are shown as contrary to the renewables that are often called the weather dependent power sources. But actually, we see right now that the weather conditions pushed to some extremes has also an impact on such as stable sources as nuclear power plants. So actually, we are losing the stability of the grid, not because of the fact that we don't have some reserve, some generational reserve, but we are actually deprived of the reserve by the extremeness of the weather that we are facing right now.
Yes, so, but here's the thing: if we have backups, if coal-fired plants are backups as well, can they not take up the slack that we lose as a result of having to run down the nuclear power plants?
Well, usually they can, but let me put it in this way. When you construct a power system, you construct it on the basis of some average conditions that you collect through the decades. For example, Polish or Hungarian or Romanian power system is constructed on the basis of climate and weather conditions taken from the 20th century. We know how many extreme heat days normally we had in 20th century. We know how many cold days we had back then, and we constructed our power system basing on these conditions. But now the conditions have changed, and we didn't adapt our power system on any other system to such rapidly changing conditions. So we are losing some possibilities or some room to react to these extreme heat waves, because of the fact that we are still basing on the infrastructure that does not reflect the current state of the climate and the climate related extreme weather events. So we have to adapt to a completely brand new reality that we are facing right now, and this is a major issue right in Central Europe, because normally we would have a lot of potential backup in the system, like, for example, stable nuclear power plants. The one that I named previously, the Paks nuclear power plant in Hungary, it generates half of Hungarian electricity. So normally it's a backbone of the Hungarian electricity system. But right now it's facing a possible shutdown because of the fact that it cannot be operated in such a severe conditions, such a severe heat event when we have such a low level of Danube River. So this is a new reality in which we have to react somehow.
So as I understand it, what you're saying is that we misjudged the impact of the weather. We didn't expect this kind of weather, and therefore we were caught, unawares. Now, going forward, I mean, the weather will cool down as winter comes along. Water will come back. How do we prepare ourselves for the next heat wave? You say it's going to be a regular occurrence. How do we make sure that we are not caught in trouble again in this way?
Well, there are no short and simple answer to that. We have to create a complex strategy that will include some significant changes in the infrastructure of our power plants, such as nuclear power plants. For example, we have to build additional ways to transfer water to the cooling systems of the existing power plants that are being cooled by the river water. But at the same time, we have to build a lot of new capacities in sources that do not require cooling by that manner. So, for example, we have to build a lot of solar capacity backed by the battery energy storages. We have to build wind turbines both on land and on the sea, and we have to build a new power plants such as nuclear power plants with the closed down, closed internal cooling system that will rely on some limited portion of water that will not depend on the flow of the rivers. So it's possible to do so. We have the technical solutions for that, but it will of course require some investment. It will require amounts of money put in this strategy to adapt to new conditions that the climate creates.
It will be expensive. It will certainly take time, Jakub. But what about the coal-fired power plants that are already in existence? Why can't we use those as backup?
The answer here is simple, because they also need cooling water, mostly from the rivers. Such situation occurs in Poland when we have where we have coal-fired power plants that are also limiting its operation because of the lack of the proper temperature of the water. So it's the same story actually, and it's not a simple solution to just start up the operation of the coal-fired power plants when we cannot operate the nuclear ones. And what's even more important, in the countries such as the countries of the Balkan Peninsula, we have some coal-fired capacity that is quite old to operate, and there is a risk of a failure that can create, let's say, blackout conditions to the system that is put under such a stress.
Understood. Jakub Wiech, thank you very much indeed for sharing your analysis with our audience.
Thank you.
And have a good evening.
My pleasure.
Thank you. Bye-bye.
Good evening.
And that brings us to the end of this episode of World Talks. Don't go away, lots more coming up. Goodbye.